So welcome back. Now that we know how to use the solubility table, so we can take two ions and determine if once those two ions come together, if we put them in water, will they separate? Will they dissolve? That's what the table tells us. So now we're gonna use it to predict the products of the reactions. If you notice on part 7a, you were writing balance equations when you were given on a paragraph, you were given the whole reaction. Now, you will only be given the reactants, and you're going to have to be able to predict what the products are going to be. But that's really easy. So follow me. So I will show you how easy that is. So these are the objectives we're going to cover now. Predict and write chemical equation for precipitation reactions. Precipitation is the formation of a precipitate. We tend to abbreviate it like this. And it's nothing more than the formation of a solid. And if something is a solid, that means, or that implies, that is insoluble. So it's the formation of ionic compounds that are going to be insoluble. That's what a precipitation reaction is. And it usually begins with two homogeneous solutions being mixed together, producing a heterogeneous solution, a mixture. And you remember that from chapter 2, if I am not wrong. And then once we do that, we're going to see that for us to be able to do that, which is going to be what we call the molecular equation, we're going to have to be able to write first the ionic equation with all the ions, so it's going to be complete with all the ions, and then we're going to see what can be discarded, what's really not important for the reaction, and whatever remains is what we call the net ionic equation. So the net ionic equation is what is in reality happening on that container. So let's see how we're going to do that, obviously with some problems. Well, not yet. So let's visualize this. So here we have a homogeneous mixture, better known as a solution. Here we have another homogeneous mixture. And when we combine them together, we see the formation of a powder, of a solid. Eventually it will settle all the way to the bottom. So when that will eventually set down at the bottom. So how are we gonna interpret this? I can tell you from experience, based on the way the product looks, that we are making lead 2 iodide, which is gonna be insoluble. And we are using, to do that, we're using lead 2 nitrate, which is a aqueous solution, homogeneous, is a solution, and probably magnesium iodide, which is another aqueous solution. So as you notice, I didn't even mention the nitrate. So what I told you, what I just told you with the magnesium iodide and the lead nitrate producing the lead 2 iodide is what is actually happening. The nitrate is not really important here. So how are we gonna do this? Well, we're gonna say if I have lead 2 nitrate, which is a solution, and which is aqueous, and I combine it with magnesium iodide, which is also aqueous, we're gonna get what? So that's the question. What are we going to get? So that's what I mean with the part about predicting. So we need to predict what we're gonna get. How are we gonna do that? Well, we're gonna say, since the lead 2 nitrate is aqueous, so it's a solution, in reality what I have is lead 2 aqueous plus 2 nitrate aqueous because it's a solution, so it's dissolved. And what about on the magnesium iodide? It's aqueous, so it's dissolved, so you're gonna have to break it into the ions like you did on the last daily work. You're gonna get magnesium 2 plus, which is aqueous, and 2I negative aqueous. Notice I didn't put I2, I sub 2, because that's not what it is. It's two ions of iodide broken apart. And then I'm gonna say, well, they are reacting. So that means that the atoms are gonna get rearranged. That's what the chemical equation is. The atoms are gonna get rearranged. So the lead is not gonna be any longer with the nitrate. The lead is gonna find something else. The lead is positive, 2 positive. So it's gonna find something negative. It's not gonna be the nitrate because that's what it was originally. It's gonna go with the iodide. So those two are gonna combine. So my product is gonna be lead 2 combining with iodide negative. So I'm gonna get lead Roman numeral 2 iodide, which according to the solubility table is gonna be a solid. And the magnesium, which is 2 plus, is gonna go with the negative, with the nitrate. And that's gonna give me magnesium nitrate, which is gonna be aqueous. So that's what's happening there. That's how you get the formation of the solid that we're talking about. So you're making a solid. So let's see how we can fine tune this. So what you're gonna make then is gonna be lead iodide, which is a solid, and magnesium nitrate. Oops, sorry. And magnesium nitrate, which is soluble according to the solubility table. So what you do, you break it into the ions, like you saw here on top, and then you swap the ions. The positive goes with the negative, the negative goes with the positive, and then you look at the table, and if the table says that that combination is insoluble, then you know you have a solid. If the table tells you that that combination is soluble, then you have aqueous, dissolved in water. So let's do this problem. Write a molecular equation for the precipitation reaction, so we know we're going to be making a solid because it's a precipitation reaction, which is nothing more than something that is insoluble. So when you combine sodium carbonate and lead 2 nitrate, can we predict what we're going to get? When we combine sodium carbonate, so sodium carbonate, so this part you should be experts now. If not, this can really throw you off, so make sure you practice that. And we're saying that we're combining solutions, so this has to be aqueous then. That is combining with lead 2 nitrate, which is going to be that. And the question is, what do we get? Can you predict that? So once more, we're going to take every molecule or formula and we're going to break it into the ions. So this is going to give me Na plus aqueous. And there's going to be 2 of them. It's also going to give me carbonate, which you have to remember is 2 negative. And there's only 1 of them. And then the lead 2 nitrate is going to give me lead 2, because the name is telling me so, which is aqueous, and 2 nitrates, which is also aqueous. So once more, I'm gonna take the positive one and combine it with the new negative. The new negative is the nitrate. So that's gonna give me NaNO3, but there's two of them, so I'm just gonna put a 2 there, and that takes care of also the two nitrates. And according to the solubility table, this is gonna be soluble or aqueous. And then I'm gonna see what I have remaining. And what I have remaining is my carbonate with the negative, with the lead-2, with the positive. And we always write the positive first. So that's gonna give me 2 plus and 2 negative, so it's just one of them. Lead-2 carbonate, which according to the solubility table is gonna be a solid. And how many lead-2, and that should be what goes in here. Na, NO3, aqueous, producing lead-2 nitrate solid. So as you notice, this reaction here, this reaction that I'm highlighting in yellow, there's no ions, so this is what I call the molecular equation. So that's the molecular equation, the one without ions, but with the products and everything, and it's balanced. Make sure that it's balanced, and this one is particularly it is. What about write the molecular equation for representation of reaction occur if any, when it's no reaction occurs, write no reaction. So that's all we have to do for this one. Write the molecular equation. But notice what we did. For us to be able to do that, we had to see it first on the ions. And we can even do that in preparation for the next objective. So for anything that is aqueous, you can separate it into the ions. And that's a very important concept. For anything that is aqueous. So when we come into the last one, that's a solid. So solids and liquids, you cannot break them into the ions. They will not separate into the ions. Solids and liquids, you keep it the way it is. And this is what we call, so this is the molecular, and this one is what we call the total ionic. And I kind of getting ahead into the next objective. So the total ionic is the one where anything that is aqueous, you break it into the ions, keeping track of the coefficients and so on. Anything that is liquid or solid, you leave it alone. You do not break it apart. Liquids and solids, they stay together. And then we have another type of equation, which is going to be the net ionic. So I'm basically covering two objectives at the same time. So the net ionic, the way you're going to do that is you're going to look at the total ionic and you're going to say, on my left side, I have 2 sodium plus. Do I have that on the right side also? Yes, so say I have it here and I have it there, so they cancel. Anything that shows on both sides of the arrows cancels. That means it was there and it's still there, so it wasn't part of the reaction. What about the carbonate? Do I have carbonate by itself on the left and on the right? And the answer is no. So that states. What about the lead? I have lead 2 plus on the left side. Do I have it by itself on the right side? And the answer is no. What about the nitrates? Well, I have 2 nitrates on the left side and 2 nitrates on the right side. So everything that cancels, because it was on both sides of the arrow, it was a product and it was also a reactant on the same amount, that's what we call the intermediates. So the intermediates are going to be the one that get canceled. So everything that did not cancel is what is going to be our net ionic. So we're going to have carbonate which is aqueous, combining with lead 2, which is aqueous, providing lead 2 carbonate, which is a solid. So this is what I call the net ionic equation, the one that shows you exactly what's happening on the reaction. We don't care about the sodium, we don't care about the nitrates because they're going to be soluble and they never come together with anything else. The net ionic reaction is, in the case of precipitation, is those ions that produce the insoluble compound or the solid compound. So let's do a B. Let me clear the screen a little bit. So what do we have for B? So for B, we're going to have potassium sulfate. So we're going to have potassium sulfate, and you should know why I put in there already. And that's going to be aqueous. If not, go back and check how to do formulas using crisscross. And lead 2 acetate plus lead Roman number 2 acetate. Acetate is -1, so I'm going to have C2H3O2 and 2 of them. And that's going to be also aqueous. And they're going to produce, what are they going to produce? Well, let's break it into the ions first. So 2 potassiums plus. So you have to know your polyatomics to realize that this is a polyatomic. So you don't break it into the elements. So you got to know your polyatomics. And lead 2 acetate will break into lead 2 and acetate, which is going to be aqueous, and we have 2 of these, right? So the positive is going to go with the new negative. So using crisscross, that's going to give me K C2H3O2, and there's going to be 2 of them. And all acetate compounds or compounds with alkali metals are going to be soluble, aqueous. So what do I have remaining? What I have remaining now is going to be my lead 2 sulfate, my lead 2 plus, and my sulfate. So when those two combine, crisscross is going to give me just PbSO4, which according to the solubility table is going to be insoluble. So this is my precipitate. So that would be my precipitate. So when we put all this together, that is my molecular equation. Okay, 2SO4, 2 potassium, 1 sulfate, 1 lead, 2 acetates, 2 acetates. So that would be my molecular equation. What about C? So far, A and B are giving me precipitation reactions. Copper nitrate, copper 2 nitrate, so that's going to be CuNO3, 2 of them, all nitrate compounds are going to be soluble, so that's going to be aqueous. And this is combining with barium sulfide, which I know is a solution, so therefore aqueous. And when they combine, I'm going to have copper 2 plus aqueous. So I need to break it into the ions to be able to see it. Plus 2 nitrates, aqueous, plus 1 barium 2 plus, aqueous, is on group 2, right? and one sulfide, which is a group 16, aqueous also. So when they combine, the positive is going to go with the new negative. So that's going to give me copper sulfide, which I don't remember if it's soluble or not, so I'm going to have to check the table. So let's write it like that for right now. And in addition to that, it's going to give me the negative with the new positive. So I'm going to get also barium nitrate. All nitrate solids are going to be soluble. So that has to be then well, I don't know what it is. I'm going to have to check. So copper sulfide, all sulfides are what? All sulfides are going to be insoluble unless they have an alkali metal or calcium, strontium, and barium, which are going to be soluble. Okay, so that should be insoluble then. So it's telling me that this is going to be my precipitate. So this is going to be my solid. Let's double check that everything is balanced. So this is basically the way this is going. So this here produces that. So one copper, two nitrates, one barium, one sulfide. And that would be my precipitation reaction. So far, all three have produced precipitation. And then I go into the last one. And the last one is going to be calcium nitrate. So the formula should be that, which I know is soluble, combining with sodium iodide, which I know is also soluble. And that's going to produce, well, let's see. Let's break it first so we can see it. Calcium 2 plus aqueous, combining with two nitrate negatives, so the 2 comes from there, which is also aqueous, combining with sodium plus, which is aqueous, combining with iodide, which is aqueous also. So when I combine my positive with my new negative, I'm going to get my calcium iodide, and we're going to see the table to see what that's going to be. And when I get my negative with my new positive, I come up with NaNO3, which I know is going to be aqueous. So the calcium iodide, let's check it just to be sure. Calcium iodide. All iodides are going to be soluble, except when any of these ions looking for calcium is not there, No, it's not insoluble with calcium, so that means this is going to be aqueous also. So if you get aqueous on both sides, that means that everything cancels, so there's no reaction. So there's no reaction happening on this one. All you do is just mix in a bunch of ions that are going to not come together ever. So no reaction for that one. So that's how we approach that. So make sure you review that and then work on this daily work. And now we have to do one more thing, and we already did it. We already talked about complete ionic, and we talked about net ionic. So for the first one, we're gonna have Ag plus aqueous plus nitrate aqueous, and I'm just duplicating that, plus K plus aqueous, and those charges are coming from the periodic table, plus chloride aqueous, producing silver chloride, which is a solid. So I'm gonna leave it like that. You cannot break apart the solids or the liquids. Plus potassium nitrate, which is gonna be K plus aqueous, plus NO3 negative aqueous. So that would be the complete ionic. Why is this one the complete ionic? Because this is an ion, this is an ion, this is an ion, this is an ion. This you cannot break, and so everything that I can break into ions, I broke it into ions. So now I can use my complete ionic to say what repeats on both sides. The nitrate is on both sides. The potassium is on both sides. So those are my intermediates, or not my intermediates, sorry, my spectator ions. So what remains? Silver plus aqueous combined with chloride aqueous, producing silver chloride. And that would be my net ionic equation. So one more, break everything that is aqueous into the ions, recombine the positive with the new negative or the negative with the new positive, check the solubility table. If that new combination is insoluble, then it's going to be a solid. If it's soluble, then it's going to be aqueous. And if once you put the ions on both sides, whatever shows on both sides has to be deleted because it's just looking at the show, it's not doing anything. And then whatever remains after canceling everything you can cancel, that's your net ionic equation. So let's do the last one. And then you get to practice. So the last one is going to be calcium sulfide aqueous, so calcium 2 plus. And I know calcium is 2 plus because it's on the periodic table, and besides, sulfur from the periodic table is negative. So the calcium has to be 2 plus. Plus copper 2, which is going to be aqueous, and 2 chlorides, which are going to be aqueous also. So when I combine that, my positive goes with my new negative. So I'm gonna get calcium chloride, which I know from the solubility table is aqueous, plus copper 2 sulfide, which I know from the solubility table is gonna be solid. So remember, this is nothing more than, so anything that is aqueous, you can break it apart. And now if they see that they are just broken apart, then I can see which ones do not cancel, and the ones that cancel, I have to cancel them. So the calcium cancels with the calcium, the chloride cancels with the chloride, so the only thing remaining is my sulfide, which is aqueous, my copper 2 plus, which is aqueous, producing copper 2 sulfide, which is a solid, so I do not break it apart. And that will be my ionic equation. This is my molecular equation. Not my molecular. That would be my total ionic. The total ionic equation. So make sure you go back to that and review it, check the textbook, go into the tutorial videos, go back into Alex, but make sure you practice that a lot. And that's your daily work. And with that said, now we know how we can predict the products. So from now on, you don't have to be given the products. You can only be given the reactants, and you have to say what the products are going to be, and if it's going to be a solid, liquid, or gas. Well, gas, we're going to do it very soon. And you can write the equation by predicting precipitation using the solubility table. And you saw how we do the total molecular, the complete ionic or total ionic, and the net ionic, which is the really important one. And with that said, we come to the end of this section. So when we come back, we're gonna start talking about neutralization reactions. So we just finished precipitation reactions. So we're gonna start talking about neutralization reactions, acid and base, and also acid and base reactions that produce gases. And those are super important for you to know. So let's leave it there for right now. See you soon. Take care.